Before we kick things off, I've got 2 quick things for you. First, do you want to push real innovation and help spark the uncomfortable but necessary conversations in the concrete industry? Support this show. When you donate, we list you as a producer of the episode because you're literally making these conversations happen. Go to concretelogicpodcast.com/donate and back the show today. Second, for a limited time, you can get free access to the Concrete Logic Academy. Take your first class on us, earn a PDH credit, and stick around for the networking and resources you won't find anywhere else in the industry. Claim your free trial now at concretelogicpodcast.com/academy. All right, let's get into today's episode.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandett.
And welcome to another episode of the Concrete Logic Podcast. And today I have Joseph E. Thomas with me. He is the Executive Director of Natural Pozzolan Association, and he's going to come on the show. I think I was sharing with Joseph before we hit record that I believe we've done an episode on natural pozzolan, but it's been so long ago that I think it's good to go back and we haven't had Joseph on the show, so it's good to hear from other folks about the same topics, and definitely want to kind of do a refresher as well. So we're going to talk about what natural pozzolan is, how it's used in concrete, how it has been used, how it's currently been used, and what the future of natural pozzolans are. Joseph, is there anything you want to share with the audience before we get started? Did I do an okay job of introducing you?
Perfect. I appreciate you inviting me onto your show, and I look forward to the discussion.
Yeah, this was a long time coming. We kind of circled around, and that's Joseph was a actual suggestion from someone, from a listener and a supporter of the show. So I always, when I find someone that's willing to do this and we don't align schedules initially, I don't quit. I'm relentless. I will stick with them till they decide that we can find a time to do it together. And Joseph is a great example of that. And I appreciate you coming on the show. So Joseph, could you share, just as a refresher, what a natural pozzolan is and how it's used in concrete?
Sure. Natural pozzolans are similar to fly ash. Most people in the concrete industry are familiar with fly ash. The difference is natural pozzolans are naturally occurring materials, mostly volcanic in origin. So when you think of pumice and pumicite and perlite and obsidian and tephra and tuff, there's so many different variations of volcanic materials, but as long as it's a rhyolitic volcanic material, it has potential to be a natural pozzolan. And in terms of what they do, of course, like the fly ash, they react with the calcium hydroxide within the concrete matrix to make additional calcium silicate hydrate, which is the binder in concrete. So it densifies concrete, makes it less permeable, makes it stronger and much more durable. And obviously, if I answer your questions and there's something you think I left out, just go ahead and re-ask.
Yeah. So where do we find natural pozzolans?
Yeah. So there's actually 2 types of natural pozzolans, and I covered the one that's naturally occurring. We call them raw natural pozzolans, and those occur pretty much wherever you have volcanic zones. So the Pacific Rim of Fire is a great example. Japan, as an example, is a volcanic island, gigantic volcanic island, and there's lots of natural pozzolans there. And, the Korea and Siberia and down through Indonesia, wherever you hear about volcanoes erupting, that's where raw natural pozzolans are produced. There is another category of natural pozzolans. We call it activated natural pozzolans. For example, most people in the concrete industry have heard of metakaolin. Metakaolin is simply a kaolinic clay that has been calcined at the correct temperature to turn it from a basically inert material to a reactive natural pozzolan. So you've got your raw material, you just dig out of the ground, grind it to size, and it works as a pozzolan. And then your other materials that do not naturally work as a natural pozzolan, as they are, but once you activate them through calcination, through mechanical activation, chemical activation, there's various ways to activate materials that are inert in terms of their pozzolanicity. But through that process, they can become reactive. And in the case of metakaolin, as an example, extremely reactive. Metakaolin is usually only used in applications where you require a very high performance concrete, 15,000 PSI, 18,000 PSI, because it's fairly expensive. You can use it in, like residential concrete if you want to have the best residential concrete in your neighborhood, but it's generally not priced for that. If I get going on a tangent, you can stop me anytime, Seth.
That's all right. We do tangents as a rule on this show, so it's okay.
All right. So clays are everywhere. The raw natural pozzolans, you have to be in a volcanic zone.
Yeah. Is there an infinite amount of natural pozzolans out there? Or is there a limited source?
Yeah, based on data from the U.S. Geological Survey, there are millions and millions more tons of natural pozzolan produced every year by volcanic eruptions than there is used and probably ever will be used. So volcanic-based natural pozzolans are certainly almost an inexhaustible supply of material.
Okay. Well, that's good to hear. It's not like I was going to make some kind of joke about peak oil, but I failed to come up with something. So you talked about what it is and some of the... So essentially, I guess to simplify it for folks that are simple-minded like me, when you use natural pozzolan, it sounds like there's attributes in it that help with strength, right? Did I hear that right? And what other things does it help concrete with, I guess?
Sure. The main reason to use a natural pozzolan is to increase the durability of the concrete. We might get into this later, but as an example, the Pantheon and the Colosseum in Rome and the aqueducts in Rome, they were all concretes based on natural pozzolan that effectively have no termination date, no end use date. They go on and on forever. Modern day concretes, you can't say that about them. However, when we restarted using natural pozzolans in the early 20th century for Hoover Dam and some of these other major infrastructure projects in the West, that concrete is still in excellent condition as opposed to other concretes that were poured 100 years ago that are, gone. Are in very bad condition. So natural pozzolans today can add the same kind of durability that the Romans put into their concrete 2,000 years ago. So durability would be number one. Probably number two in our day and age is that for every pound of cement that you replace with a natural pozzolan, you're lowering the carbon footprint by somewhere between 90 and 95%, which is a pretty huge deal. So even with the natural pozzolans that are calcined, you still reduce the carbon footprint of that concrete by upwards of 70%, because the calcination process in producing a natural pozzolan uses far less energy than does the production of cement clinker, which you've got the BTUs put into the clinker in terms of heat, and then you've got the calcium being released from the calcium carbonate. So cement has a very high carbon embodiment compared to natural pozzolan. So I'd say those are the 1-2. The 1-2 punch is make a concrete that's extremely durable, and then at the same time, one that is much more sustainable, much lower carbon footprint than a standard concrete with just cement. There are others. I could go on for a long time, but
yeah, I was going to add, I think last time we talked about a kind of an internal cure attribute to it as well. But before we get on that tangent, you said something interesting, which I don't think I knew that. The Hoover Dam, they used natural pozzolan. Is that what you said?
Correct. And Glens Canyon Dam. Actually, if you go into U.S. Bureau of Reclamation website, you can find over 100 dams that used natural pozzolan in the early 1900s through about 1970. And, the question, well, why did they stop in 1970? Well, because in the 60s, this material called fly ash started becoming abundant as coal-fired power plants tried to find ways to use their fly ash. And it turned out that fly ash had a pozzolanic characteristic to it, similar to natural pozzolan. And it was free. They were giving it away. And so the natural pozzolan industry in the last century kind of died out as it was replaced with a very inexpensive substitute known as fly ash. So, natural pozzolans are coming back. Why? Well, for a couple of reasons. Fly ash obviously is becoming less and less available due to the decommissioning of coal-fired power plants. But the second reason is because the effectiveness of a natural pozzolan, I don't think we're going to have time to do this on this podcast, but, I've got reams of data that shows, comparative durability characteristics of natural pozzolan versus fly ash. And the natural pozzolan is a much better material in terms of increasing the durability of your concrete, reducing the permeability, increasing the strength, reducing the heat of hydration. All of these things come into play, especially on big projects like dams, where you need to lower your heat of hydration. Natural pozzolan does that better than any other material you could use.
So I didn't catch it. Did you say which natural pozzolan was in the Hoover Dam?
It was a pumiceous pozzolan, not too far from the dam site, actually.
Okay, that makes sense. So they found something nearby and just utilized it. Huh. That's a new one for me. I have to check that out. So this is it's a natural pozzolan. So it's a natural occurring pozzolan.
Correct.
So how are these formed? Volcanic eruptions. What else? I guess.
Yeah. So I mentioned earlier, there's the two types. There's the raw and there's the calcined or activated natural pozzolan. So wherever you've got clay, you can activate that clay and turn it into a natural pozzolan. And that's virtually anywhere. Clays are pervasive, geologically speaking, across the world. So for a volcanic material, there's a couple things that have to come into play. Essentially, two types of volcanoes, or magma, I should say. There's a mafic magma, which produces the basaltic materials. For example, the island in Hawaii that's erupting all the time, and you see the rivers of magma. That's a low viscosity mafic magma that produces basalt. And that's not necessarily a good material for natural pozzolan. There are some basalts that have some reactivity, but most do not. So it has to be, number one, a rhyolitic magma, meaning that unlike the magma that flows like a river in Hawaii, rhyolitic magma is extremely viscous. And so it builds up in the earth through tectonic processes and eventually just explodes. Out here where I live in Idaho, there's all kinds of deposits from the Yellowstone chain of volcanoes through Idaho and Wyoming and up into Montana. And so those produce rhyolitic, magmatic, natural pozzolans. However, the big caveat is if they're too old, they eventually There's a term called devitrification. It means that they convert from their glassy state to a non-glassy state, which means that it's no longer useful as a natural pozzolan. The reason natural pozzolans work so well is because they're very soluble. You put them in the concrete, the alkalinity of the concrete basically melts the natural pozzolan. It reacts with the calcium hydroxide, forms more calcium silicate hydrate, and that's why you get the great durability and the great strength. So not all volcanic deposits, even if they're rhyolitic, are good natural pozzolans. If they've devitrified or lost their glassy state, they're not useful as a pozzolan.
Huh. And what do you mean by glassy state? Could you clarify that?
Okay, so there's basically two types of materials, geologic materials. There's crystalline materials and there's amorphous materials that have not formed into a crystalline structure. And crystalline materials do not solubilize well in concrete at all, actually. They're very, in terms of their resistance to being affected by the alkalinity, like sand. Sand is a crystalline material. The alkalinity in the concrete does not affect the sand. But you can have a natural pozzolan that has very similar chemical characteristics. In other words, high crystalline or high quartz content or high silica content. But if it's a natural pozzolan, it's not crystalline, it's amorphous. Based on that amorphous structure, it will solubilize in the concrete matrix. And that's the big difference.
Is limestone a natural pozzolan?
Limestone is not. Limestone is, a pure limestone, calcium carbonate. So you've got your calcium and you got your carbonate, and they obviously use that to make cement. And when they fire that material, the carbonate portion of the calcium is burned off, and that's one of the reasons why cement has such a high carbon content or carbon emissions. Some calcium carbonates or some limestones have a little bit of silica in them, but generally speaking, they're crystalline and they're not amorphous.
And you said earlier that you can trade a 1-for-1. Is it so? Replace cement with natural pozzolan? Did I hear that right?
Yeah. So there's a limit, obviously. You need the calcium component. So you can replace up to, I would say, in some instances, 50% of your cement content in a concrete mix design. Typically, you're looking at 25% to 30% because most concrete producers and users want or need a high early strength. And you can still do that if you're 20% replacement of cement. But up to 50%, which is useful for things like dams and mass concrete projects, the early strength is not there, but it does catch up. It just takes longer. So the amount you can replace depends on how quickly you need the early strength or the strength to build up. And if you can wait a while, then you can replace a lot of your cement with natural.
Is there any other limitations to a natural pozzolan, its use?
Yeah. So one of the biggest impediments to using natural pozzolan, as seen by the current concrete industry, is water demand. Let's just say that cement has 100% water demand. Give it an index number of 100%. Fly ash is generally in the 95% range. So you can add fly ash to cement and actually lower the amount of water you need for that concrete to be plastic and to pour and to be worked easily. So when you add natural pozzolan, instead of 95, you go from like 100 to 105 for the raw natural pozzolans. So you have to use more water, or you have to use more high-range water reducer to meet the same slump as you do with 100% cement. So this creates an issue for folks that are bound by like state or federal water cement ratio prescriptions. They'll say, for this project, for this canal or this road, we are prescribing a water cement ratio of 0.4. And so for the natural pozzolan guy to compete, The concrete mix design has to have more high-range water reducer to meet the slump requirement of that 0.4 water cement ratio concrete. So that kind of prices a lot of our guys out of the market because high-range water reducers are expensive. And we're working on a lot of studies right now, Seth, where you can use water to attain that slump as opposed to high-range water reducer. In other words, you use the same amount of high-range water reducer as you do with your normal cement or your normal concrete mix design, and then add extra water with your natural pozzolan to meet the slump. And what we find is when we do that, the permeabilities, the resistivities, all of the metrics that we measure to determine durability are as good or better with the NP-based concrete using extra water. But that's a huge paradigm to try to shift, and it's going to take some time.
The water demand comparison, is that based on the new cement, type 1L cement, or a blended cement, or what was that compared to?
So when I say 100% index for a cement, it can be a type 1-2, it can be a type 1L, it can be any type of your normal Portland cements. You just basically measure a flow on that cement or a slump on that cement, and that's your standard. It doesn't matter what type of cement it is. And we call that standard 100% so that we can then decide if we replace 20% of that cement with fly ash, what happens to that number? Well, with fly ash, that number goes down. You only need 95% of the water that you needed with 100% cement to have the same slump or flow. And just the opposite with natural pozzolan, you might need 105% of the water to hit the same flow.
Yeah, I was just curious if it's the higher content of limestone, which has a high water demand as well. There's some additional water demand issues with a 1L cement, that's for sure. Yeah. So you mentioned the dam projects using natural pozzolan. Could you give us some idea of what type of projects that you're seeing now that are using natural pozzolan, so get an idea of what an ideal project is?
Yeah, well, there aren't a lot of dams being built these days. Everywhere you currently use cement or cement and fly ash, you can use a natural pozzolan. So it's being used in everything, residential, highways, the giant wind farm, concrete blocks that the windmills are placed on and in. There really is no restriction. Again, the only restriction would be when a DOT or some other specifier says, we want this concrete to have a water cement ratio of 0.42. And that means that whoever's making that mix design is going to have to add extra water reducing agents to meet the slump of that concrete. And there is no restrictions in terms of, what kind of concrete it can be used in. We're working to fix the issue with DOTs. ACI 318 is kind of the reason all of these different agencies have water cement ratios prescriptions, because ACI 318 has that. We tried to put a performance spec along with the prescription spec, and it was voted down by, I think, one vote. And so next time that we go into ACI 318, I'm pretty sure we're going to be able to put a performance spec in there that says, as long as you meet all of these, performance specs in terms of strength, in terms of alkali silica reactivity mitigation, sulfate mitigation, as long as you meet all of these performance specs, it doesn't matter what your water cement ratio is.
Yeah.
And once that happens, then, the floodgates will open, so to speak.
Gotcha. What about, is it, we all know that concrete is a local produced product, and it's subject to what's available to it nearby. It's a very local product. I don't understand why more architects don't start designing everything out of concrete. It's the most, earth-friendly local product that you can build with. But anyhow, is that another issue with natural pozzolans? I don't even know if this is a word, regionality. Is that a word? Regionality of it. So where like the Hoover Dam example that you gave, it was something that was nearby, so easy access. So I was just wondering if that's a roadblock as well. So maybe out where you are, natural pozzolans would be much easier to utilize versus where I am. I'm basically on the East Coast. So you're competing against fly ash. There's a lot of fly ash over here. Not good fly ash, but there's fly ash. So is that a impediment as well?
Absolutely. You can only ship this material so far, and then you've exceeded the price point that the concrete folks can live with at this point in time. So, yeah, out here in the West, there are, we've got a map that shows all of the places that natural pozzolans are being developed in the United States. And the vast majority of those are in the Western United States, because that's where all the raw natural pozzolans are, which means that's the less expensive natural pozzolans. However, from the Rocky Mountains east, we are seeing a plethora of new developments using shale and clay, where they, as I mentioned earlier, they activate them through a calcination process. And obviously it adds cost, but when you compare the cost of trying to ship a natural pozzolan from, say, Colorado to Virginia, that calcination cost doesn't look too bad. And so even in Virginia, there are startups, a shale startup in Virginia, to convert waste shale products into natural pozzolans, and they work really, really well. There's an extra cost to them. And as you mentioned, there's a lot of fly ash out there. So it's a more competitive market, but it's happening. I'm looking at the map now, Missouri and Alabama and Georgia and South Carolina, Virginia, Maryland. All of these places are developing activated natural pozzolans.
Why do you think that there's a sudden surge of it? Is this sudden, or is this something that's been, building?
Two reasons. Number one, the total amount of available fly ash is going down. And the second reason is that fly ash that is still available, you mentioned it a minute ago, some of them have issues. One thing about natural pozzolans is they're generally consistent in terms of their performance, and you don't have to recheck them. Like a fly ash, you might have to check each batch that comes in to make sure it's the same as the last batch. And then if it's not, you make adjustments to your mix design. When you have to do that all the time, then it starts making a natural pozzolan look more attractive, even though it costs more money.
Gotcha. And I assume that's the ready mix suppliers that are initiating that demand, or who's initiating that demand?
Yeah, ready mix and precast, both. The precast guys, do things really fast, and they don't like having to check or recheck the material coming in to see if it's the same as the last batch that came in. So precast is a big one. Ready mix is obviously the biggest. I mean, it's the greatest volume of concrete in the country. And so out here in the West, there's a lot of ready mix being used with natural pozzolans. But little by little, you'll see that uptick in the East as well, with activated natural pozzolans coming online in the next couple of years. You'll see a lot of precasters and ready mixers start using natural pozzolans in the East.
That'll be interesting. The precasters can have a little bit more flexibility in utilizing that material than, I would say, like you said earlier, about trying to get DOTs and, government type entities to use a product like that. Well, I think this is a good time to wrap up today's show. If folks want to reach out to you, Joseph, and learn more about natural pozzolans, what's the best way?
Well, first of all, there's pozzolan.org, where you can go to learn about natural pozzolans. And then if you have questions, you can send them directly to me at info@pozzolan.org. So info Pozzolan.
All right. That's easy. We'll get that in the show notes. So with each episode, if you're listening to this, make sure you check out the show notes. It'll have Joseph's contact information. There's other resources in there as well for our listeners. Joseph, thank you for coming on the show today. Appreciate your time and teaching us about natural pozzolans. And folks, until next time, let's keep it concrete.
Thank you, Seth.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia